Welcome to the next installment in my video lecture series for microeconomic principles. And in this particular video lecture, I'm going to be taking a look at a potential test question or problem from Chapter 8. And it's going to be this particular problem right here. Assume a perfectly competitive market, and the firm in question is a profit maximizer. Graphically illustrate a firm operating at a profit or a loss. I'll illustrate both of those to you using price, marginal revenue, demand, average total cost, and marginal cost. Be sure to show the areas of revenue, costs, and profit/loss. So I'll go through both of those scenarios for you, and that's how you should have it labeled. You should have price, marginal revenue, average total cost, and marginal cost on the y-axis, and on the x-axis, quantity. So remember, this is a perfectly competitive marketplace. So in a perfectly competitive marketplace, price and demand is equal to marginal revenue, and it is horizontal. So this is what price, demand, and marginal revenue is going to be equal to. So we have demand is equal to price is equal to marginal revenue. Let me change that up a little bit so it looks a little bit better on the video. So in a perfectly competitive marketplace, remember the market sets the price and each individual firm accepts that price. So the price is fixed for individuals, and that also means that the marginal revenue is equal to the price, because if the price is fixed at a certain amount, every increase in a level of output, so if this firm increases output by 1 unit, total revenue is going to increase by the price, so marginal revenue is going to equal the price. So that's number one. Make sure you remember that. That's the first thing that you should realize as soon as you hear a perfectly competitive marketplace, that demand is equal to price is equal to marginal revenue, and it is horizontal. Let's illustrate a firm, and let me actually move this down to here. It might be a little bit easier to illustrate doing that. So let's illustrate a firm, firm that is operating at a loss. So if we have a firm operating at a loss, the easiest way to illustrate that is to have an average total cost curve that is above your demand curve. Because of this, your per unit costs are always higher than the price you're selling at. So this firm is always going to lose money regardless of regardless of its level of output. So let me make that right around 40. So there's our average total cost. So regardless of where this firm sets output, average total cost is always greater than the price, which means this firm is always going to lose money. So if you were asked to illustrate a firm operating at a loss, just have the average total cost curve above the demand curve, and you're guaranteed that this firm will be operating at a loss. Next, let's make sure we draw in our marginal cost curve. So let's draw in marginal cost curve here. Remember, we have a J-shaped marginal cost curve. So we have a U-shaped average total cost and a J-shaped marginal cost curve. Average total cost is U-shaped because remember what we talked about previously, that total cost includes fixed and variable costs. And remember that at the beginning stages of output, average fixed cost is very high. So as we start increasing output, we're spreading those fixed costs out amongst more and more units. So average fixed cost is declining, which is decreasing average total cost. Also, marginal cost is below average total cost, so that is keeping average total cost moving downward. And then what happens is that marginal cost is going to start increasing. We're going to have decreasing marginal returns on labor, where it's going to take more and more individuals to be hired in order to increase output the same level. So our per unit costs are going to be pulled upward. And also the impact of average fixed cost, as we spread those units out, the cost over more and more units, the impact of quantity gets less and less. The figure I showed you before was average fixed cost was quite steep at the beginning, and then it kind of levels off as quantity gets much greater, and it starts to, average fixed cost actually starts to approach zero. So make sure you remember that we have a U-shaped average total cost curve at a J-shaped marginal cost curve, and that marginal cost should intersect at the minimum of average total cost. Now, this firm is a profit maximizer. That was in the description. So profit maximization occurs where marginal revenue is equal to marginal cost. So where marginal cost intersects marginal revenue, that will give us our profit maximizing output level. So this point here, we go straight down. And let me change that to a dotted line. So that will give us the profit maximizing output level. Now, I'm sure some of you are saying, Guy, what are you talking about? You said this firm was going to lose money. How could you maximize profits when you're losing money? Well, if you're in a scenario where you're always going to lose money, if you maximize profits, what you end up doing is minimizing your losses. So this firm, by using the profit maximizing condition, will actually be minimizing its losses. And if you think about it, if you're always losing money and you're in a scenario where you're minimizing your losses, by default, that means that you are maximizing your profits. So let me actually insert a, where did it go? Edit. Emojis and symbols. Didn't come up for me. So let's just call this pi. There we go. Thank you. Took a little time. My favorites. I'm sure pi is in there. Yes, it is. So we have Q pi is the profit maximizing output level. Pi is the shorthand for the symbol that economists use for profit maximization. Let me make that font size. So the profit maximizing output level occurs where marginal cost intersects marginal revenue. So at this output level, this firm is maximizing profits, and because this firm is actually always losing money, it is minimizing its losses. So you're asked to show the areas of total cost, total revenue, and profit or loss. So let's take a look at where total cost is going to be. And let me actually move this dot up until it hits. Whoa, what did I do? Whew, scared me there for a second there. Made the window transparent by mistake. All right, so if we go from Q pi all the way up to average total cost, and then we move to the left over, this rectangle that we've made right here is going to be equal to total cost. Remember, average total cost is total cost divided by Q. So if we take average total cost and multiply by Q, we get total cost back again. So let me actually highlight that. And this is whatever color this happens to be. Don't know the name of it. Don't really care, to be honest with you. So this entire area here is total cost. So we've shown the area of total cost by going, let's review that we selected an output level where marginal cost equals marginal revenue. So that gives us Q pi. If we go from Q pi all the way up to average total cost and across, this area right here is total cost. That's average total cost multiplied by Q. If we want to find out what total revenue is, we go from Q pi up to the demand curve. So that region right there is total revenue, because total revenue is QP times Q. Let me actually get out of this, move this out of the way here. So here we go. Let me change the color of that to something a little different. Let's make it to gray. So this area here is total revenue. So total cost is this right here. This entire area here is total cost. The bottom part here is total revenue. So what we have left over is going to be losses. So if total cost is greater than total revenue, the difference between those two will give us our losses. And let me highlight that particular area, and we'll make it red. So this area here is the area that illustrates the level of losses. Okay? So that's how you answer the question if you're asked to show a firm that is operating at a loss. You could also be asked to do the same thing, but to illustrate a firm that's operating at a profit. Let me get rid of that. And let me actually move this down a little bit because I'm going to be using that. So if you want to illustrate a firm that's operating at a profit, the way to do that is to have average total cost below the demand curve. Because now this firm has a profit potential, right? Here we have an area where we have price greater than average total cost. Sorry for that little delay there. So for example, let me actually highlight this for you. This region in here, I managed to pull that one off without screwing it up. All right, as long as we're between this point and this point here, this firm is going to be making a profit. So this firm has an area where it can make a profit. What we're concerned with is selecting the output level that maximizes profit. So what is the profit maximizing condition? It's where marginal cost is equal to marginal revenue. So where marginal cost intersects marginal revenue, that will give us our profit maximizing output level. We go from that point straight down, and that gives us the profit maximizing output level. Again, we do the same exercise. Here, let's illustrate total revenue first. Total revenue is P times Q. So if I go from Q pi up to the demand curve and across, this region in here is going to be profits. So let me actually select, and let me change that color. I'll make the revenue equal to blue. So this area right here is total revenue. So if we take Q multiplied by P, that gives us total revenue. Let me actually make that color a little less bright. Okay, a little less intense. So this light blue region is total revenue. Why is that total revenue? Because it is P times Q. P times Q is total revenue. Now, in order to determine what the level of profits are, I have to know what total cost is. And total cost is Q pi multiplied by average total cost. So if I go from Q pi up until I touch average total cost and go across, that will give me the area of total cost. So if I go from that point straight over, the area in the bottom here is going to be total cost. And let me actually highlight that for you. Let me change that, and I'll make it a light red. So this area in the very bottom part is total cost. So we have total revenue, P times Q. We have total cost, average total cost times Q. So if we subtract total cost from total revenue, we will actually get the area of profit. And let me make that a gray area there. So this is the area of profit. So make sure you're comfortable with this. In particular, not only this perfect competition, make sure you remember, number one, that as soon as we make the assumption of perfect competition, that's what your demand curve looks like. It's horizontal, which means that demand is equal to price is equal to marginal revenue. So as soon as you hear that assumption of perfect competition, that's the first thing that you should visualize is that. Remember your U-shaped average total cost curve, your J-shaped marginal cost curve, and that your marginal cost curve should roughly intersect the minimum of your average total cost curve. As I said in class, you don't have to have it exactly right. Right here, you could see that mine does not exactly intersect at the minimum of average total cost, but as long as you're approximately correct. All right, as long as you don't do something crazy like have, now these are all attached to one another. That if your marginal cost curve was over in this region here, you would lose points for that. But as long as you're relatively close with that. Also realize what is the profit maximizing condition? That is where marginal cost is equal to marginal revenue. You go straight down from that point, and that gives you your profit maximizing output level. And once you have your profit maximizing output level, you can determine what total cost, total revenue, and profits are for this particular firm.